IAL C12 May 16 question number 13. Show that the equation 2 log y base 2 is equal to 5 minus log x base 2. Whenever you find a number in this, try to convert it into log. So how we convert it? We have log base 2, we don't know this number, and that is equal to 5. So 5 can be written as log of a number base 2. 2 power 5. So it can be written as 2 power 5. That is 32. So instead of 5 I can write log 32 base 2. So this equation becomes log, this 2 will be the power of y square. 5 is log 32 minus log x base 2. So that is equal to log 32 over x base 2, log y square base 2. Now take antilog, so we'll just write this. So it will be y square is equal to 32 over x. Y square is equal to k over x. So k is here 32. So that was the part A. Part B. Hence or otherwise solve the simultaneous equation. So equation number 1 is same, that is y square is equal to 32 over x, and second equation can be written as x to the power minus 3. The same way we have written here, x to the power minus 3 is equal to y. Let's square both sides. So x to the power minus 6 is equal to y square, and y square is 32 over x. Let this x multiplied by there, so it will be x to the power minus 5. This will be x to the power minus 6 plus 1, x to the power minus 5 is equal to 32. It means 1 over x to the power 5 is equal to 32. So x to the power 5 is equal to 1 over 32. Can be written as 1 over 2 is to the power 5. So x will be half. So now we use this equation to put the value of x. So y square is equal to 32 over x. X is 1 over half. So that is 32 multiply 2, that is 64. So y is equal to plus minus root 64. No, not plus minus. Y is equal to root 64. So it will be plus minus 8. So y is equal to 8 and minus 8. But we have a condition here, y is greater than 0. So we discard this. So we have x is equal to half and y is equal to 8. And that is the solution of these simultaneous equations. Here we can see the graph looks like a quadratic but made up of the straight lines or the line segments. One line is given with the equation y is equal to half x, and this is y is equal to gx, so it's half x. This one, it consists of 1, 2, 3 lines segments, minus 3, 4, 0, 4, 2, 0 and 4, 10. line L intersect GX at point A and B. Use algebra to find the x coordinate of the point A and the x coordinate of point B. Use algebra means simultaneous equation. Let's talk about this point. First, we have to find the equation of this line. Equation of line joining two points, that is 0, 4 and 2, 0. We know the equation of line joining x1 y1 and x2 y2 is y minus y1 is equal to y2 minus y1 over x2 minus x1 x minus x1. So that will be the equation of the line joining Q and R. So let's say this is x1, this is y1, this is x2 and this is y2. So we put these values here. Y minus y1 is 4 is equal to y2 0 minus y1 4 divided by x2 2 minus x1 0 x minus x1 0. So this is y minus 4 is equal to minus 4 over 2, that is negative 2 x. So this is the equation of line. So we can say that this is y is equal to minus 2x plus 4. So this is equation of QR. This is equation of QR and this is equation of line L. So QR and L, they are intersecting here at A. So y is equal to half x. That is equation of L1. They are intersecting, so it means y is equal to y. So we have half x is equal to minus 2x plus 4. So x will be minus 4x plus 8. 5x is equal to 8. So x will be 8 over 5. And the y will be half 8 over 5. That is 8 over 10. This can cancel by 4. So that is 4 over 5. So it's asking only the use algebra to find the x coordinate. So you have to write only x coordinate of A. There is no need to write the y coordinate of A. Now we have to find the B coordinate. The same way we are going to write this. For this we are going to write, now we have the points. We have the point 4, 4, 10 and 2, 0. So it is x1, y1, x2, y2. Y minus y1 is equal to y2 minus y1 over x2 minus x1, x minus x1. So y minus 10 is equal to minus 10 over minus 2, that is 5. So this is 5x plus minus 20. So we have y is equal to 5x minus 10. This is plus 10. So this is the equation of SR. And it is intersecting with the equation L1. And the equation of L1 is y is equal to half x. Now these two are simultaneous equations, so we can write that half x is equal to 5x minus 10. X is equal to 10x minus 20. So this is minus 9x, or 10x minus x is equal to 20. So x will be 20 over 9. So that is the coordinate of the x coordinate of point B. So this is point A, the x coordinate of point A, and this is the x coordinate of point B. Now sketch the graph with equation y is equal to 3 over 2 gx. Let's say the points of gx. We have point P, then we have Q, R, S. The coordinate of P is minus 3, 4. Q is 0, 4. R is 2, 0. And S is 4, 10. Y is equal to 3 over 2 gx. And this is from minus 3 to 4. 3 over 2 gx. It means the y coordinate is multiplied by 3 over 2. So what we are going to do is multiply y coordinate by 3 over 2, multiply 3 over 2, multiply 3 over 2, and multiply 3 over 2. So the gx coordinate will be -3 and 6. This is 0 and 6. This will be 2 and 0. And this is 2 times 5, so 4 and 15. So these are the new coordinates, and you draw the same equation using these coordinates. So this is minus 3, minus 3, 6, 0, 6. So x is minus 3 and says 6. And 0, 6. Two 0, 4, 15. Then 2, 0, and 4, 15, if this is 15. So that's how you are supposed to draw this. The important thing here is to find the coordinate, and that is one of the easiest method to find these coordinates. When y is equal to afx, it will affect only y coordinates. And if it is y is equal to f(ax), it affects x coordinates. This is a water barrel. It is in the shape of a right circular cylinder with a height h and radius r centimeters. It has a base but no lid. It's open at the top and made of a material of a negligible thickness. The barrel is designed to hold 60,000 centimeter cube of water. It means its volume is 60,000 cubic centimeter. Show that the total external surface S of the barrel is given by pi r square plus 120,000 over r. Here you can notice there is no h. If you write the formula for surface area, that will be the surface of this, the area of this circular thing. This is pi r square. Then this area, when you open this area, will be like this. This is h, and this is this circumference. The circumference is 2 pi r. So this area will be 2 pi rh. So plus 2 pi rh. Now you can see here h is not there, but somehow the multiple of 60,000 is here. So let's try to find the value of h from here. So volume of a right circular cylinder is pi r square h. So h will be 60,000 over pi r square. We put this value of h here. So it is pi r square plus 2 pi r h is 60,000 over pi r square. So this is pi r square plus 60,000 multiplied 2 is 120,000. Pi and pi cancel, r power 1 power 2, so this is divided by r. So that is what we are supposed to prove. Part B. Use calculus to find the maximum value of surface area to 3SF. For maximum value, let's find ds over dr. We differentiate surface area with respect to the radius. So this will be 2 pi r, 2 will come here, plus r is to the power minus 1. So this will become minus 120,000 r to the power minus 1 minus 1, so r to the power minus 2, that is r square. And for maximum minimum, ds over dr is equal to 0. So we multiply here, so it is 2 pi r cube is equal to 120,000. So r cube is equal to 120,000 over 2 pi. So r is equal to 26.73009, 26.7, up to 3 significant figures. So that is the value of r. Use calculus to find the minimum value. So we put R is equal to 26.7, so S is equal to pi 26.7 square plus 120,000 over 26.7. The S is supposed to be up to 3 significant figures, so that is 6, 7, 3, 0 is the value of S. Justify that the value of S you have found in part B is a minimum. So again we have to find d2s over dr square. So that will be equal to, this is 2 pi and this is minus, this is r to the power minus 2, so this will be plus 2 120,000 over r cube, and this is positive and this is greater than 0. So if d2s over dr square is greater than 0, the value is minimum. Question number 16. It shows the sketch of a part of a curve C with the equation y is equal to x, x minus 1, x minus 2. With this equation we know this is 0, this is x is equal to 1 and this is x is equal to 2. Point P lies on C and has x coordinate 1 over 2. So the y coordinate will be, y will be half minus 1 is minus half, and half minus 2 is minus 3 over 2. So that will be 3 over 8. So this is 2 and 3 over 8. This is the coordinate, P coordinate. This is 1 and 0. This is 2 and 0. L1 as shows in this figure, this is the line L1. Find dy over dx. So let's go to part A. Dy over dx. So first, what is y? Y is, we have to multiply this. So it will be x square minus 2x minus 1x, so minus 3x plus 2, and this all multiplied by x, so this is x cube minus 3x square plus 2x. This is the value of y. So dy over dx will be 3x square minus 6x plus 2. Use part A to find the equation of L. This is the dy over dx and this is a tangent. So this is a tangent. So dy over dx at x is equal to half. It will be 3, half square is 1 over 4 minus 6, half plus 2. So that is 3 over 4 minus, this is 3 plus 2 is minus 1. So this is minus 1 over 4. So equation of tangent is y minus y1. We have already calculated it. 3 over 8 is equal to minus 1 over 4. X minus x1 is half. So this is 8 y minus 3 over 8 is equal to minus 1 over 4, 2x minus 1 over 2. This 4 times 2 is 8 and 8 cancel. 8y minus 3, this is minus 2x, so it will be plus 2x plus 1, minus and minus plus 1, so minus 1 is equal to 0. So the equation will be 2x plus 8y minus 4 is equal to 0, or the equation can be written as x plus 4y minus 2 is equal to 0. This is the equation for line L. It says we have to write in the form of x plus 4y is equal to 2. That is the correct answer, the way it's asking. Find the finite region R. The finite region R. Show that the shaded is bound by the line L and the curve the x. So the line L meet the curve at point 20. Yes. Use the integration to find the exact area of shaded region R. We have to find the area of this region. We have to find this area, so let's see. Let's say this is Q and this is S. So we have this triangle. So area of this triangle is half base. This Q is half and this is 2. So on the axis this line is starting from half and ending in 2, x. So this will be 2 minus 1 over 2. So that is 3 over 2 base. And this height is the y coordinate of P, 3 over 8. So multiply 3 over 8. So this is 9 over 32. Now we have to find this remaining area, and so from this point to this point, if we find the area under the curve, so this is area under the curve. So if we calculate this one, so now this green area is between the curve and the x-axis. So we can calculate this area. This is area under the curve. So we have to write the equation of the curve. That is 3x cubed minus 6x square minus 3x square minus so that is x cubed minus 3x square plus 2x dx, and limit is from half to just here 1. So this will be equal to, this is x to the power 4 over 4 half to 1 minus its integration will be 3x cube over 3, and the limits will be half to 1 plus this will be 2x square over 2. Limit same, half to 1. So this 2 and 2 cancel, 3 and 3 cancel, so it will be, so that will be 1 over 4. 1 is to the power 4 minus half is to the power 4, that is 16, minus 1 minus 1 over 8 minus plus 1 minus 1 over 4. So this will be 15 over 16. So that is 15 over 64 minus 7 over 8 plus this is 3 over 4. So that will be, let's take LCM as 64. So this is 15 minus 8 times 8 is 64. So multiply both by 8, that is 56 plus 4, 16 times 4 is 64, that is 48. So this is 7 over 64. So this area is 7 over 64. So R will be 9 over 32 minus 7 over 64. So that is 64. 18 minus 7. So 11 over 64. That is the area of this region. Find the area of shaded region. So this is the area. So this is the end of C3, C12, May 16. Thanks for watching, and please subscribe my channel. Thank you.